OMIS 351, Unit 4, Information Technology Foundations Part 2, Telecommunications and the Internet, and Securing It All. Where have we come from? Unit 1 gave us an overview of solving business problems using information technology solutions. Unit 2 gave us an idea of how to evaluate those solutions in a strategic framework. And Unit 3 talked about hardware and software. So we have these wonderful devices and we have these ones and zeros that are flying around very quickly and being remembered almost perfectly by our devices. Unit 4 talks about let's not have those isolated. It's no good to me as a business person if the ones and zeros are flying around very quickly on my phone or my computer, but I cannot share them. So Unit 4 talks about connecting these devices and sharing them, allowing collaboration and connectivity. So it is a connectivity unit. Once again, we have a participation quiz discussion guide. There's why it's important. High-level diagram here. All telecommunication comes down to a picture like this. When I was a kid, we would sometimes empty out a soup can and connect it with a string to another empty soup can. I would shout into my soup can and my friend would stick his ear into his soup can and we would be playing telephone. The string, the media, the connectivity media in this case, actually vibrated. A little more modern version of this is some of the playgrounds designed for you when you grew up. They would have a funnel, a metal funnel with a metal tube going underground to a different part of the playground. And there'd be another metal funnel, and you would scream into that, the metal funnel being the terminal, the tube being the media, and your friend would hear your voice on the other side of the playground, and so you were playing telephone across the playground. We add in some complicated stuff here as our discussion will continue, but this is the basis of connectivity and telecommunications. We want to start with what's called plain old telephone service, or POTS. That's a real acronym. Also called Public Switched Telephone Network, PSTN. What we think of as normal telephones. So if you think of the soup can model or the funnel model, two people wanted to talk. So they got terminals, they got some sort of a media, and they connected them. But then, of course, you don't just want to talk to one person. And so if I was going to talk to a second person, in that example, I would need a second terminal for this person. That person would need a terminal, and we'd reconnect. Well, if we did this with every person on Earth with whom we'd want to be able to have the potential to connect with, it would be a mess. And so some genius came along with the concept of a switch. All telephones would be connected to this central office switch, CO, and then they would be reallocated. So if this phone wanted to connect to this phone, it would be reallocated by the last four digits of your telephone number, referred to as the exchange. So my office telephone number is 815-753-6381, and my exchange is 6381. That four-digit number identifies a particular telephone connection on a particular switch. So if you think about that, one central office, this is not meant to be a trick question, because 0000 is one possible exchange. So you can have 10,000 phones connected to a single central office switch. Of course, we have more people than 10,000, and so something called a LATA connects switches. The LATA is defined by the prefix of the telephone number. So if NIU has the three prefixes 753, 752, and 756, they would be able to connect up to 30,000 telephones, each of these representing a switch, each switch having a capacity of 10,000. And that's somewhat true there, that NIU is about a 30,000 person organization. If you run out here, then we move across something. If we cross a boundary, these are defined by these originally geographic boundaries, defined by the first three numbers of a telephone, the area code. Chicago, back in the day, all the phone numbers were 312 area code. As you probably know, this has become less meaningful over time because companies are letting us keep our 10-digit telephone number. So if I move to California, I have a 630 telephone number. You may have an 815 from DeKalb, but we could keep that with our cell phone company as we move to California. So while these once area codes defined a geographic boundary, that's become much less meaningful. But nevertheless, it defines where the phone was born geographically. That's still true. And so you can see, if you live in California with a 815 area code, somebody might say, are you from DeKalb or Western Northern Illinois? That'd be very astute of them. Okay. So that's kind of the basics of the public switched telephone network, PSTN, really the network that Alexander Graham Bell helped to create. But these are called circuit switched calls. Think again to the soup can and the string. A circuit switched call means you dedicate the line. The string is dedicated to you. The two of you are the only ones using it. Why? Because the voice vibrates the string. And if you're thinking about this, you might say, well, how else could this possibly be done? And the answer is the genius innovation called packet switching, which is how the internet and the World Wide Web are connected. This allows messages to travel many paths. Let's take a look at a picture, a simple picture. These lines are connections. The W's are web servers, so those are computers that serve up web pages, and together they form the World Wide Web, this of course being a simple picture. We have 4 companies in our picture, and we have an internet backbone. We learned in the last unit that all computer communication is composed of ones and zeros. So let's take a simple, overly simple example here and say this is the message. Whatever message company A wants to send to company D is going to be composed of ones and zeros. So it's a big string of ones and zeros. So they have this message and they want company D to receive it. If it was circuit switched, it would have to follow one path. It would only have one choice. Packet switching says because we're using ones and zeros, we can break it up into packets of a specified length, chosen by the protocols of the telecommunications network being used, and then reassemble it at its destination. Why is this genius? It's genius because think if the pandemic completely ended and we decided as a class that we want to have a big party at John Barleycorns in Chicago. And we said, okay, everybody come out to DeKalb, and we're going to get in a big line of cars, and we're all going to drive on Interstate 88 down to John Barleycorn. In that case, we'd be one long line of cars. Now, why is that bad? Well, let's say there's an accident or construction on Interstate 88. Then we would all sit still. Um, let's say Interstate 88 is crowded, it's rush hour. We would all go slower. The idea with packet switching would be you let the packets pick their own fastest and cheapest route. So it really enhances communications. In the case of our analogy, that would be, we would say, just meet at John Barleycorn's at 7 p.m. Some of you might take the train, some of you might take the L, some of you might take your car, some of you might take a bus, some of you might share a ride, but you would be like packets. You would all just arrive at the destination. And you could take ways that were the cheapest for you, the fastest. You could check traffic, you could check prices, you could take a helicopter if you had the means to do that. So that's kind of how packet switching works. TCP/IP, big mouthful here, Transmission Control Protocol, Internet Protocol, is the dominant packet switching protocol. What does that mean in English? It is the most used set of rules, that's what a protocol is, a set of rules and conventions for how it works. So TCP/IP tells us things like, what are the size of the packets? What happens if the server over here does not receive, in this case, all 4 packets? You know what it does? It sends a message back that says, I only got 3. How does it know that it only got 3? This protocol, among other things. The first packet will say, you should expect 4 total packets. And then this server knows, the software in the server knows, if it didn't get 4, something's wrong. So this is just brilliant, and it's happening at high rates of speed, and we, the users, rarely see degenerated messages anymore. Most of our messages are pretty clean, pretty good. And that's because of this common set of rules. And this is very important, but that is one of 3 things that really was behind the explosion of the internet. So many times companies fight each other and try to have their own proprietary way of doing things. Proprietary meaning just their own way that they can make money off of. But way back when, started by education institutions and the Department of Defense, they got together and said, let's all speak the same language. Let's all use the same protocol. They did that, and it was an important time in history. It allowed the internet to grow rapidly and essentially at the point where we are now cover the entire earth, which is awesome and amazingly powerful for us as business people. So 3 things responsible for the explosion of the internet. One of them was this TCP/IP, a common language, a common protocol. Second one was the ease of use and ubiquity of a browser. If you think of a browser, I have taught people to use a browser in under 5 minutes. You say type the location, or you teach them to go to Google, and search what you want and then use the back button. I mean, so a browser is easy to use, and ubiquitous means seeming to be everywhere at the same time. So it's not hard to find a browser. I mean, even if you lost your computer, you could go to the library, you could go to a terminal. Many places where you could get a hold of a browser. So that's the second thing. And the third thing are the devices that route this traffic. So there is hardware and software on these web servers called routers. And the routers are the traffic cops of the internet. And they basically tell these packets, you should go this way. This way is going to be faster. This way is going to be cheaper. And the routers are on these web servers, and they act as the traffic cop to get the messages, to get the packets to their destinations. So that's what the answer to this is. Those are called routers. Okay, we want to expand this picture a little and say, wow, there's all this fun stuff happening on the internet. Stock prices, sports scores, weather forecasts. I mean, the internet is amazing, right? So the people who are on the public switch telephone network, the normal telephone network, they want to participate. Grandma over here wants to be able to check her stock prices, whatever it is. So we've expanded our packet switching network to connect it to the circuit switch network, and we're going to make it all work together. How are we going to do that? This is called the 6-box diagram. As you can see, there are 6 blank boxes, and we are going to fill in 6 terms and make them a one-to-one match. And this is always going to appear on your quizzes, so it's good to think this through. So you can see the first one that's asked about is the green box right here. Well, this is something called a modem, and I'm going to change my pointer if I can. This is something called a modem. And I've had to switch to presentation mode, which doesn't quite fit in your picture here, but I'll pull it back in. So this is a modem. And why? Modem stands for modulate, demodulate. And what that means in English is switching from the analog waves of the PSTN and converting those to ones and zeros, which go over the internet. And then when the ones and zeros come back for stock prices or whatever is coming back, that's converted to analog waves so it can be seen by grandma who has an old telephone connection and old network. I'm going to keep those changes, and then you can see that. I'll go back and forth. So that first one is modem. The second one, pointing at internet backbone. That's here. That's going to be fiber. Why? Well, think of Interstate 88. What materials do they use to construct Interstate 88? They use the best materials possible. Why do they use the best materials possible? They know there's going to be a lot of traffic on Interstate 88, and they don't want to rebuild it a lot. Similar, the internet backbone, they want the fastest, best landline media. The fastest, best landline media available today is fiber optic cable. Fiber optic cable allows pulses of light, on-off pulses of light, to serve as the ones and zeros of the digital network, and it is the highest capacity. It is recognized to be the best. So it is used kind of as the analogy of the interstate highway. Believe it or not, there is fiber optic cable laid on the ocean floor to connect continents for international business. If you search on YouTube, you'll see a boat unspooling fiber optic cable and letting it fall down to the bottom of the ocean so the information needs of the continents can be connected. Pretty incredible, really. So that's fiber. What goes in the second to upper left box in front of company A? That's here. That's going to be firewall. So if you think of firewall, let's write that in and then bring it back down. Get my pen. And I'm crossing out terms to remind myself as we go. Forgot to cross out fiber, firewall. Why is this a firewall? The analogy I like to use for a firewall is a moat around a castle. If you ever read those sort of stories as a kid, oftentimes in medieval times when they had a castle, they would protect themselves by digging a trench around it and filling it with water and alligators to protect so people could not enter their castle. Similarly, a firewall wants to protect your internal networks and your internal information from all the bad entities out here on the internet, and there are many. So how does that work? It's hardware and software that does not let people come into your network. But what if you have a trading partner? Let's say company D is your friend and you want them to get into your network. Well, in the castles, they had a drawbridge and they would say some sort of a password. In the cartoons that I saw, it would be open sesame. And they said open sesame and the drawbridge would open and the friendly people could come in. Similarly, if you want trading partners or customers to be able to see something that you're protecting, you give them a username and a password. So that works really well. But the point of a firewall is to protect your network. So that's a firewall. How about the lower middle box pointing over consumer 2 right here? That's DSL. Why? Consumer 2 wants to participate and browse the internet, but they have a normal phone connection. They want high speed. We all want high speed. The only way to achieve high speed over normal telephone wires is through something called DSL. Stands for Digital Subscriber Line. It's incredible physics that allows the ones and zeros to go at very high speed over twisted pair copper wire, which is what the normal telephone network uses. So if you're at home and you don't have cable available in your area, the only or one of the only good high-speed options to you will be DSL. Multiple arrows pointing out of it. That's this one. Well, these arrows could be pointed all over the diagram. This is going to be TCP/IP because that protocol is the common protocol, one of the 3 reasons responsible for the explosion of the internet. It's used all over. So these arrows could go many other places. Let's write that in. Sorry if this is irritating. You can see why I don't use the draw on PowerPoint very often. Process of elimination says this is frame relay, the last box. We'll talk about that in a second. So that's TCP/IP, and then the last one, what is frame relay? Frame relay is a packet switching protocol. It's a packet switching protocol like TCP/IP, widely recognized to be not as good and not as common. So why would anyone use it? Well, this acronym, WAN, stands for Wide Area Network. And so before the internet, companies often physically connected each other through WANs, and in some cases digging trenches and laying down media to connect. And back in the early days, the best available packet switching protocol was frame relay. Why does it continue today? One of those big words that we use, momentum. It's working for them. They're not going to switch the protocol and change over the switches and redo everything just because there's newer packet switching protocols out there. The best packet switching protocol in modern times is considered to be ATM, asynchronous transfer mode, not automated teller machine at your bank. It's another packet switching protocol, but why is it not used all over? Again, because of the momentum of TCP/IP. Which of the following is not? Okay, well, you answer this question on your participation quiz by remembering that the three that are: routers, browsers, TCP/IP. Those were the three things that were responsible, so anything else listed is not. What about this? If Verizon promised me an all-digital network, what does that mean? Well, let's keep going. Here is this spelled out. And it includes FTP. What is that? When you did your Google site and sent information, you were sending information like a picture of yourself or your Excel calculations, whatever it was. You were sending it to the Google web server. You didn't know it, but you were using FTP. That's how those files get back and forth. This is the protocol for email. This is a really neat way to use another computer, something like WebEx. Sometimes you can see somebody else's screen. That's what terminal emulation means. HTTP it's the rules that allow you to view web pages on other web servers. And SNTP allows the management of network nodes.